Hello everybody, I am Dr. Jagdish Chand Bansal from South Asian University, Delhi. I am also working as a visiting research fellow in Liverpool Hope University, UK. Today's talk title is Nature Inspired Optimization. So I'll speak basically on nature inspired optimization and particularly on swarm intelligence algorithms, spider monkey optimization, particle swarm optimization, artificial bee colony, ant colony optimization algorithms. I will also introduce in brief the two evolutionary algorithms, biogeography based optimization and genetic algorithms. I will also introduce some success stories where the nature inspired algorithms have successfully applied. So the nature inspired algorithms are basically those algorithms which are inspired from one or more natural phenomena. There is no mathematical validity behind the development of these algorithms. There is no mathematical derivation of the update equations used in these algorithms. So these are actually the inspired algorithms and not the derived algorithms. So there are another category of algorithms which we can say mathematically derived algorithms. So these are not the mathematically derived algorithms but the nature inspired algorithms. Broadly, nature inspired algorithms can be classified into three parts: swarm intelligence algorithm, evolutionary computation algorithms, and the artificial neural networks algorithm. In this talk, I will concentrate myself only on the swarm intelligence. I'll also speak in brief about the evolutionary computation also. So when I say the swarm intelligence, the first question arises in our mind that in which area it lies. So I would say that swarm intelligence is actually a part of artificial intelligence. So when in the artificial intelligence, when the intelligence emerges through iterative computation, then it is a computational intelligence. And when this iterative computation is based on the collaborative behavior of a group of individuals, then that computational intelligence is known as swarm intelligence. So swarm intelligence is basically the emerged collective intelligence among a group of simple agents. You can see here, it's a just 10-second video. So here in this video you can see that there are certain birds on this tree, and suddenly they started flying in different directions, and after few seconds all the birds started flying in a same direction. So they have some communication medium, they communicated with each other and they found that this particular direction is the most optimal direction for our movement, and therefore after some communication, after some time collaboration between each member, they have one consensus to fly in this direction. So that consensus is in terms of intelligence that is emerged through the collective efforts among these birds. So actually the swarm intelligence is is due to collective efforts among a group of simple agents. The word simple here in this definition is very important because the swarm intelligence is expected to emerge only among the individuals of the same capacity. If there are some birds and there are some monkeys and you make a single group, then the swarm intelligence may not be expected. So to have the swarm intelligence, there are certain conditions. The very first condition is that the group of agents should be homogeneous, means all the individuals in the group should be of same capacity, and one should not be more intelligent than other initially. So this is the list of few popular swarm intelligence based algorithms. I hope most of us must have heard about particle swarm optimization algorithms. Algorithm which is introduced in 1995 by two US scientists. Ant colony optimization algorithm is another one which is inspired by the ants foraging behavior of ants. Artificial bee colony algorithm is another one which is based on the foraging behavior of honeybees. Recently, myself and my two students and one one my research collaborator from France, Maurice Clark, who has a very pioneer work in particle swarm optimization. We four people worked on this algorithm, spider monkey optimization, and introduced this algorithm in 2014, which is based on the foraging behavior of monkeys, spider monkeys. So, if I talk about evolutionary computation, which is another category of swarm intelligence, then this is evolutionary computation algorithms are basically based on the Darwinism principle, survival of the fittest. So, evolution is an optimization process where the aim is to improve the ability of organism to survive in dynamically changing and competitive environments. In all the evolutionary computation algorithms, the biological evolution operators are used, for example, reproduction, mutation, recombination, natural selection, and they are actually based on the survival of the fittest principle. Some of the popular evolutionary algorithms are genetic algorithms. I think everybody must have heard of this algorithm: genetic programming, evolutionary strategy, evolutionary programming, cultural algorithm are the few evolutionary algorithms. Very recently, this biogeography based optimization algorithm was also introduced by one US scientist, Dan Simon. And my favorite algorithm is this differential evolution, which it's not absolutely I can put in the category of nature inspired algorithm or in the category of evolutionary computation. Actually, there is no some a fixed natural phenomena which is behind the development of differential evolution, but in the development of differential evolution, the operators are the same which are used in genetic algorithm or in some other evolutionary computational algorithm, but with some modifications. So I have put this differential evolution in the evolutionary computation, but there is no absolute classification of differential evolution in the category of evolutionary computation. So let me just quickly explain you how the spider monkey optimization algorithm works. So similarly, I'll speak this for other algorithm also. Uh, the spider monkey optimization algorithm is based on the fission fusion social structure of spider monkeys. Spider monkeys is a monkeys which live in the deep forest, and when they suspend themselves with their tail with the help of a tree branch to the tree branch, then they look like a spider. So they are called spider monkeys. They have a very special kind of foraging behavior, and this foraging behavior inspired us to develop an algorithm, to develop a nature inspired optimization algorithm. So how this fission fusion social structure works, let me explain this to you. That there is a group of monkeys. Out of this group of monkeys there is a leader. However, in swarm intelligence, the central control or the leader concept is not allowed. But here, since this leader in our algorithm, we consider this leader as the best solution of the current swarm. So this leader concept is actually a dynamic concept, is not indexed based, but is based on the performance. So this leadership is given to based on the performance. So here this is a monkey. Usually it is in the real life situation it is really a usually it is a female monkey. So here the group of monkey start foraging in the morning, and whenever they found the food they start eating the food, and after some time they may feel the scarcity of the food in that particular area. Then these spider monkeys do what they do to avoid the competition, because to have a good swarm intelligence behavior the cooperation should be there should not be competition, right? So the cooperation should be there. To maintain the cooperation, what they do, they divide themselves into two smaller parts, and these two smaller parts will again have the leaders, and these leaders are the best solutions of that particular smaller groups sub swarm. So we call them the local leaders, and now this leader is known as the global leader. So we have the two kind of leaders: global leader, which is the best of the entire swarm, and the local leader, which is the best of a particular group. One of the local leader is also the global leader. So whenever they feel the scarcity of the food, they divide themselves into smaller groups. Here we define in our algorithm that scarcity of food as the algorithm is not improving the solutions, algorithm is not giving you the better solutions. So in that case, we decide that let us divide the entire group into two smaller groups, and when further these smaller groups start searching in different directions, and if again this smaller group find the scarcity of food, then that group will again divide themselves into smaller parts, and this process continues till evening. So evening, in the real life situation it is evening, but in our algorithm we define this evening as the maximum number of groups are formed, or the minimum number of monkeys are reached to a single group, because you can expect a swarm intelligence behavior from a group of individuals only the group has minimum number, some sufficient number of individuals in that group. There are certain studies which suggest that if it is less than 10, then the swarm intelligence behavior is usually not expected. So what I put here in our algorithm, that the minimum number of monkeys are 10, or based on the total population, whatever, this is a parameter of the algorithm, whatever you decide that the maximum number of groups you want or the minimum number of monkeys you want in a single group. So this we defined as a evening. So in the evening the monkeys return to their habitat, and then they again share the information with each other that okay, I went in this particular direction of the forest, I went in this particular direction of the forest, so that in the next morning they can choose the best direction for their food, right? So these monkeys has this special kind of foraging behavior which makes them which enable them to do the efficient search in the forest for their food. This algorithm has been applied to many engineering optimization problems throughout the world. People are working on this algorithm. Constraint versions, binary version, discrete optimization versions, multi-objective optimization versions of this algorithm have been developed. A simple Google search can give you the web page of this algorithm, from where you can download the codes of this algorithm in MATLAB, in Python, C++. Okay, another algorithm is this particle swarm optimization algorithm, which is inspired by the birds flocking or fish schooling behavior. So here this algorithm was introduced in 1995 by two US people, James Kenyon and Russell Howard, and this is based on the collaborative behavior of fish or the birds. Another popular algorithm is this artificial bee colony algorithm, which is developed by the Karaboga and his colleagues. This is based on the foraging behavior of honeybees. Honeybees have a very special kind of foraging behavior. When they move to the field to collect the nectar, they collect the nectar from a flower, fill their stomach, and return to the hive. And on the hive, they unload the nectar, and then they do the dance on the different parts of the hive. And there are three different kind of dance: waggle dance, tremble dance, and the round dance, which is based on the distance of the flower from the hive. So in this waggle dance usually is a more popular dance, which is done in a particular direction, which is making certain angle with the sun position, which gives the information to other bees that the flower is in this particular direction. And this duration of the dance, the speed of the dance gives the other information. I have a very small video on the foraging behavior, foraging behavior and the waggle dance of the honey bees. You can see here that the bees are this bee is collecting the nectar. This bee is collecting the nectar, and then she returns to the hive. Now she is performing this dance, is a waggle dance, and this duration of the dance gives the distance, and the speed of the dance gives the amount of the food. Speed of the dance gives the distance of the flower from the hive, and the duration of the dance gives the information about the amount of the nectar in that particular flower. And the taste of the flower is checked by other bees by touching the antenna of this dancing bee. One more algorithm is this ant colony optimization algorithm, which is nowadays the one of the most popular algorithm for discrete optimization problem. And in my opinion, also I agree that this is one of the best algorithm for discrete optimization problems. It is based on the foraging behavior of ants. What the ants have a very special kind of foraging behavior. When ants start the food foraging, they leave their nest in search of the food. So initially the ants can choose any path, whether it is longer path or smaller path. So randomly choose any path. So ants keep on moving to random paths, various paths. uh, During this movement, they always remember to deposit a pheromone on the path, and this pheromone has a property that it evaporates with time. So the longer paths will have more evaporation rate, and the shorter path will have less evaporation rate. The next time when the ant uh, starts from their nest, they will also keep in mind that they will give more probability, they will give more chance to move on the path which has high concentration of the pheromone. So the longer path will have the high evaporation rate, so less concentration of the pheromone, while the shorter path will have high concentration of the pheromone. So the ants will keep on, more and more ants will keep on choosing the shorter path. So after some time, only the shortest path will remain and the longer path will disappear. So in this way, ants always find the shortest path from one point to another point, and this algorithm can be applied, this concept can be applied very efficiently for the robotic path planning problems, and of course for the drones also. Biogeography based optimization algorithm is actually in the category of evolutionary computation, which is based on the migration of species from one island to another island. So suppose here the islands are the solution. Here in this algorithm, islands are representing the solutions. So suppose this is the one solution, this is another solution, this is a population of solutions, and this is one feature which is representing one independent variable. Then the new solutions are actually formed by dividing the one emigrating island and one immigrating island. So the features are emigrated from the good islands to the poor islands, and in this way the poor island becomes the stronger island, means the poor solution becomes the stronger solutions. Genetic algorithm, I hope no needs introduction. It is based on the Darwinian theory of evolution, Darwinism principle of the survival of the fittest by John Holland introduced this algorithm in mid 70s, and this is the operators of the genetic algorithm. Encoding, we do the first of encoding according to the problem. Selection operator is applied, then the crossover operator is applied. In the crossover operator, two parents mate and they produce two offsprings, and in this, out of these two parents and two offsprings, only the two best will survive, two the weakers will die out. In the mutation, a small change is done in the solution or in the individual. Elitism is an optional operator which ensures that the top solutions are not modified during this crossover or mutation operator. So this is just to speed up the algorithm, this is just to increase the convergence rate of the algorithm. Let me share some success stories of nature inspired algorithm also. This is just a very small video of the drone swarms, which is, this video is taken from this research paper, optimized flocking of autonomous drones in confined environments, which was published in 2018 in Science Robotics. This algorithm was developed based on by the researchers from Hungary, Netherlands and Norway. So this video, in this video, a group of drones fly together, then they are not colliding with each other, and this flight is fully autonomous, nobody is controlling them, there is no central control, all the drones have the same configuration, they are flying together by maintaining a certain distance. So these kind of drone swarm can be utilized for the HADR scenario, human assistance and disaster relief scenario. We can utilize this, we can use these drone swarm for the delivery, for the war, we can use for the unmanned war, for the delivery, for the HADR scenario, the swarm drones are very much applicable. Another is this Shinkansen N700 bullet train of Japan. This aerodynamic shape design was designed by the genetic algorithms, and the Japan Railway Central site says the development of this nose shape incorporated the latest analysis method, which is genetic algorithms. So the genetic algorithm has helped in designing this aerodynamic design of the bullet train. There are other application also of these nature inspired algorithm in railways, in design, scheduling, allocation, fault diagnosis. Uh, Another application which I recently did of nature inspired algorithm, particularly the biogeography based optimization, is the wind farm for the wind farms. What I did, the wind turbines annual energy output depends upon the wake effect also. So when the location of these turbines plays a very important role in the wake effect, because the production of one wind turbine, production of energy of by one wind turbine affects the production of another wind turbine because of this location. So to minimize, and this effect is known as the wake effect. So to minimize this wake effect, we have optimized the locations. We have found the optimal location, optimal coordinates for these wind turbines using biogeography based optimization, and the results of the annual energy output are significantly better than the case when they are not optimized. We have recently published this paper in the Review in Energy Systems. So there are thousands of the applications of nature inspired algorithm, thousands of the publications. Every day people are developing new and new nature inspired algorithms also, and applying to various engineering design problems. So this verifies that it has a potential to solve the problems of today. There is a statement by the famous mathematician Euler that there is nothing in the world which cannot be thought of something of minimization or maximization. It means most of the problems, what the Euler want to say, that every problem can be thought of as an optimization problem. So if you have an optimization model, then the nature inspired algorithms can be applied to that optimization model, of course with varying efficiency levels. So what I suggest that in the nature inspired algorithm, potential research areas are the parallel. We can develop the parallel variants of the available nature inspired algorithms. We can develop the multi-objective variants of the available swarm intelligence or nature inspired algorithms. We can design new algorithms in this category, or we can apply these algorithms to a new application problems. So this is the three phases of the application. We need to model the problem as an optimization model. For that model, we need to develop an algorithm, a nature inspired algorithm, and then of course we need to implement that to hardware also. The no free lunch theorem says that there is no single algorithm which can be regarded as the best algorithm, or which can solve all the problems of the world. So there is always a requirement of a new and new algorithms, because every day people are posing new and new problems. So there is always a requirement of the new algorithm. So and the nature has the enough inspiration to develop the algorithm. So the nature inspired algorithm has potential for the development. I say that best AI is CI, best artificial intelligence is the computational intelligence. Also, I say that out of many CIs, the best CI is swarm intelligence. Thank you very much.